Hey everyone, and welcome. So today, we're going to dive into something that it feels kind of like a magic trick, but it's actually one of the most powerful forces in the universe. We're talking about the hidden force of numbers that explains everything, from a simple piece of paper all the way to the stars in the sky. All right, let's kick things off with a challenge that sounds, completely impossible. What happens when we take just an ordinary piece of paper and we just keep folding it? I want you to just pause and really think about that for a second. A thin, flimsy piece of paper reaching the moon? It sounds ridiculous, right? Well, let's just follow the numbers and see where they take us. So, we start folding. After 10 folds, the paper is just over 1 centimeter thick. That's about the width of your pinky finger. Not very impressive so far. It definitely doesn't feel like we're on our way to the moon yet. But let's keep going. After just 7 more folds, we're at 17 now, the thickness has suddenly jumped to over 130 centimeters. That is more than 4 feet tall. Whoa. Okay, you can see how quickly things are starting to speed up. Now let's jump way ahead to 30 folds. Get this. The paper is now about 10.7 kilometers thick. That is the typical altitude where commercial airplanes fly. We've gone from the width of a finger to cruising altitude in just 20 more folds. Something really powerful is going on here. And here it is, the incredible conclusion. Believe it or not, by the 46th fold, that piece of paper would be thick enough to actually reach the moon. That's not a trick. It's just the pure, mind-bending power of math. So what is this incredible secret? How does a piece of paper turn into a ladder to the stars? Let's pull back the curtain and see what the magic is all about. The secret is surprisingly simple. With every single fold, the thickness doesn't just add a little bit, it doubles. It literally doubles. The growth starts off really small, but each step is twice as big as the one before it, and that compounding effect, that's the whole key. And this phenomenon, it has a name. It's called exponential growth. It's not like regular growth where you just add the same amount each time. No, this is multiplicative. You're multiplying by the same number over and over, and the results, as we just saw, can be, well, astronomical. Now, writing 2 times 2 times 2 times 2 over and over again is, let's be honest, pretty tedious. Nobody wants to do that. So naturally, mathematicians came up with a brilliant and much more powerful shorthand to describe this kind of growth. For instance, after 4 folds, you're multiplying 2 by itself 4 times. That's easy enough to write out. But what about 46 folds? I mean, we totally run out of screen. So instead of that long, messy chain of multiplication, we can just write this, 2 to the power of 4. It's clean, it's simple, and it means the exact same thing. So much better, right? Let's just quickly break this down. The big number on the bottom, the 2, that's called the base. That's the number we're actually multiplying. And the small number up top, the 4, that's the exponent, or the power. It just tells us how many times to multiply the base by itself. And this right here is where you really see the difference in power. Look, adding 4 to itself 3 times gets you 12, but multiplying 4 by itself 3 times, that's 4 to the power of 3, that gives you 64. The results aren't even in the same league. It's a totally different ballgame. Okay, so once you get the hang of this new language, this language of exponents, you can learn a few super simple rules that make working with these big numbers surprisingly easy. Just think of them as shortcuts. Here's the first one. When you're multiplying 2 powers that have the same base, the same bottom number, you just add the exponents together. So p to the power of 4 times p to the power of 6 just becomes p to the power of 10. See? Super simple. And the rule for division? Just as elegant. If you're dividing 2 powers with the same base, you just subtract the exponents. So 2 to the 4th divided by 2 to the 3rd is just 2 to the power of 1, which is of course just 2. Easy. Now, this is not just some abstract math concept that you only see in a textbook. Exponential growth is a fundamental pattern of the universe. And once you know what to look for, you start seeing it everywhere. Let's take a look at a classic riddle that shows this perfectly. Imagine a magical pond with a single lotus flower in it. Every day, the number of lotuses doubles. And on day 30, the entire pond is full. So here's the question. On which day was the pond only half full? Now, your first instinct might be to say day 15, right? Half the time. But remember how doubling works. If the pond is completely full on day 30, It had to be half full just one day before, on day 29. So, to handle this kind of mind-blowing power, scientists and engineers came up with a really clever system. It's called scientific notation, and it lets them write these unimaginably huge or tiny numbers in a way that's compact and easy to understand. With this tool, we can suddenly describe these massive quantities so easily. From the population of a city like Mumbai to the number of seconds in a human lifetime, or even the estimated number of stars in the entire universe, all without writing out these endless strings of zeros. And that brings us to our final thought for today. When you see a number like this, which part is really telling you the story? Which part holds the real power? Is it the 2 out in front, or is it the 7, the exponent that tells you how many zeros come after it? The answer to that question tells you everything you need to know about the awesome, incredible scale of exponential growth.